Next minute, physics. You've performed your experiment and you've collected your data. Now the task is to find the relationship between the two variables. That is, to find a mathematical equation that will link together your independent and dependent variable. If you get a straight line graph, you can say that y is proportional to x. So your equation will be in the form of y equals mx plus c, where m is the gradient. For a nonlinear graph, the shape of the curve will tell you what sort of equation you're going to get. Y is proportional to x squared, y is proportional to the square root of x, or y is proportional to 1 over x. The value m is the gradient constant, but to get the gradient constant, you'll need to find a straight line graph. If y is proportional to x squared, then you'll need to plot y versus x squared. If y is proportional to the square root, you'll need to plot y against the square root of x, and if y is proportional to 1 over x, you'll need to plot y on one axis and 1 over x on the other axis. From this straight line graph, you can calculate the gradient using rise over run, just like you would for any other straight line graph. So here's a worked example. We've measured the length of a pendulum, and for each length we've recorded the time that it takes to do one oscillation. If we plot time versus length, we get this graph, which suggests that time is proportional to the square root of length. We're going to plot period versus square root of length, so we need to find each value of square root L. So it's just a case of getting the value of L and taking the square root. Period is going to go on the y-axis, square root of length is going to go on the x-axis. I plot my period values and my square root L values, and I get a nice straight line. I draw a line of best fit with my ruler, and I measure the gradient. My final equation is going to be period is equal to the gradient multiplied by square root of length. As a point of discussion, I can compare the theoretical equation with the experimental equation that we found from the graph. 2 pi over the square root of gravity will give me a theoretical gradient. In this case, the theoretical equation very closely matches my experimental equation. Choice. Another thing I can do is take my experimental equation and derive a value of gravity from that equation. In other words, take the equation with the gradient and rearrange to make g the subject and solve for g. Then I can compare this value to what it should actually be. In this case, comparing 9.87 to 9.81, which is what it should be. Next minute, physics.